Okay, this video is about polar coordinates. This is in section 10.7. This is part 1. Polar coordinates are a different system for graphing points and equations. So first of all, what you are used to are rectangular coordinates. So if you have a point P and its coordinates are x comma y, in this system you have two perpendicular lines, the x-axis and the y-axis. Where they meet, you call that point the origin. And the coordinates of a point are given as directions from the origin. You would go x units along the x-axis and y units along the y-axis, and that's how you locate where point P is. And you can see it forms a rectangle. All right, now polar coordinates. Here we will be doing r comma theta. In this system, you will have a point and you'll have a ray. The point is called the pole, or sometimes called the origin, and this ray is called the polar axis. A point P then is described with an r value and a theta value. You are describing r is the distance from the pole, so that is r, and theta is the angle that this segment makes with the polar axis. Okay, so for example, if we have a point P, which is 4 comma 30 degrees, all right, so here's the pole, we'll call that point O. You would need to mark off a 30 degree angle from the polar axis, so we'll just roughly say that this is 30 degrees. And then you would measure 4 units, whatever system you might be using. This would measure 4. That would be, here is where point P is. Right? So r is what you call the directed distance from the pole. And we say directed, it has a direction. It can be positive or negative. Positive going along the angle, negative going the opposite of the angle. And theta is a directed angle from the polar axis. And again, it's directed, so it can be positive or negative. If it's positive, it'll be going counterclockwise from the polar axis. Negative, it'll go clockwise. So r and theta can be negative. Theta being negative, you're used to. R is a little different, and we'll see some examples. Okay, if we have this set of coordinates, 4 comma negative 330 degrees. This actually represents the same point as 4 comma 30. So one point has multiple representations. So if you just picture 4 comma negative 330 degrees, so if this is your polar axis, you would rotate in a negative way, would be clockwise 330 degrees, has you going out at the same angle as the 30 degree one. And if it's r is 4, then this will be the same length here. And so that's why 4 comma 30 degrees and 4 comma negative 330 degrees represent the same point. Now, another representation would be if you had negative 4 comma positive 210 degrees. Okay, so 210 degrees. Well, we would know if we went this way, that'd be 180. So it would be 30 additional past 180s. So here would be 210 degrees. Now, if it was r was positive 4, then you would go out 4 units along the 210 degrees. But since it's a negative 4, then you're going to go in the opposite direction of this 210, and so you would be going this way 4 degrees up to the right, and that is the same thing as going 4 degrees along the 30 degree. And this would be where point P ended up. So if you have a negative r, you'll actually be going the opposite way. You'll be going on an at an angle that's 180 degrees difference, all right, or pi if you're doing radians. Okay, now when you are graphing points, you can just draw them like this if you want. You can look at how they do it in the book. There is also such a thing as polar graph paper, all right, and it comes in a lot of different styles. This is just one particular one that I found. So what they do is they put all these concentric circles so you can see how many units you've gone from the origin. So that helps you measure out your R value. This one doesn't have a lot of circles, so if you had to, you could count by 2 or what have you. And the angles are marked off very small. This here, if you go in degrees, that would be 0 degrees. And then they've got 30 degrees, 45 degrees, 60 degrees, 90 degrees. Of course, you can also do it in radians, and then you're looking at pi over 6, pi over 4, pi over 3, and pi over 2. Here's a different kind of polar graph paper. This one, if you look at, say, just a fourth of it, you can see these are in equal increments. So it's got 30 degrees and 60 degrees marked off nicely. You'd have to estimate 45. There's some graph paper, you pull it up, they'll go by 15s. So they'll have a 15, a 30, a 45, a 60, and a 75. Or sometimes they'll just go by 10 degrees. So it really varies. All right, so just some sample points to practice graphing. If you were gonna do 4, 90 degrees. So you're gonna measure 90 degrees, and it's all from the polar axis as always straight to the right. So 90 degrees will be what you're used to straight up, and you would count 4 spaces. So 1, 2, 3, 4. Here's where point A would be. All right, 2, 5 pi over 3. So I got one in radians. So 5 pi over 3, if you go all the way around, is going to be here. All right, so 5 pi over 3 is the same thing as 300 degrees. This one, the R value is 2, so you would go 2 units. So here is where point B went. All right, in this one, the R value is 0 and the angle is 60 degrees. So when your R is 0, you are going to end up at the pole or the origin. So that's where C is. Doesn't matter what the angle is. Okay, this one here, R is 3, and we've got a negative angle, negative 2 pi over 3. So that will bring us over here, and then we're supposed to go out, and here's the 2 pi over 3, sorry, negative 2 pi over 3, 3 units. So from the pole, 1, 2, 3, so there's where point D would land. All right, now here we've got a negative R. So you're going to want to find your angle, but then go in the exact opposite direction. So if you find 5 pi over 6, that would be here. All right, but instead of going out 4 along that one, you're going to go 4 the exact opposite. So 1, 2, 3, 4. So here's where E is. All right. Now, if you don't like the negatives, and they are a little confusing sometimes, you can switch that to a positive, and you're like, well, 180, that's on the opposite side of the circle from 5 pi over 6. So what's on the opposite side? You could either think of that as negative pi over 6, or you could think of that as 11 pi over 6. You're very free with polar coordinates in general to choose different ways. Okay, here's one other one though. We've got a negative R. So maybe just right away you're like, I don't like working with that negative. I want to switch it to a positive. So then you need to move this to the exact opposite side of the circle. So you could either add pi or subtract pi. I think adding pi is a good option since it's already negative. So if I add pi to it, negative pi over 2 plus pi, that's going to give me an alternate representation. And that works out to be 2, pi over 2. So if I find the angle positive pi over 2 and go 2 units, that's where point F will be. Okay. All right, so in general, if you want a little bit of a rule for it, if you have r comma theta, another representation would be keeping r the same, but you could add or subtract 360 degrees to your angle, or if you're in radians, you could add or subtract 2 pi, because that gives you a coterminal angle. So it's going to end up at the same place, all right? Or you can switch your r to the opposite. All right, now this looks like r is positive and then here it's negative, but really r could represent a negative number, and then the opposite of r ends up being a positive number. So you can change r to be the opposite sign, and then you need the angle to be on the exact opposite side of the circle. So you would take your theta and add or subtract 180 if you're doing degrees, or you could add or subtract pi if you're doing radians. Okay, so one last type of problem. These are very much what's in the book. Find 3 additional polar representations of the point using negative 2 pi is less than theta, which is less than 2 pi. Okay, so they're restricting theta to be within there. Okay, so we've got this point here, 4 comma pi over 3. So one thing we could do, we could just keep the r the same, and if we want, we could subtract 2 pi. So then that would work out to be 4 comma negative 5 pi over 3. All right. Now, if I add 2 pi, then this will be too large for the directions, because it says theta has to be less than 2 pi, so that would be too large. It would be another representation just in general, all right, but we can't use it for this problem. All right, then the other thing we can do is we can change r to be the opposite. So I can make it negative 4. So if you make it the opposite sign, then you're going to take the angle and you're going to add or subtract pi. So if I do pi over 3 and I subtract pi, that'll be fine. That'll give me negative 2 pi over 3 for the theta value, and that fits in the range. If I add pi, that'll also still fit in the range. I'll have 4 pi over 3. So here's 3 additional ones that they had in mind.